Connolly. I started making videos for my own students, and now I want to make sure we get as many students learning as possible during this crazy time. So if you're watching this and you want to share with somebody, make sure you do. The videos are for grades 1 through 5. If you have a topic you want me to cover, connollymathathome@gmail.com. Okay? So today for math time, we are going to be thinking about multiplying a 1-digit number by a 4-digit number. Okay? There are a lot of different ways to tackle this problem. That's the cool thing about math. We can be flexible. We can break up numbers in many different ways. The goal here is going to be keeping track of our work. So here's what's going on. I like to give every problem a story problem context so we can keep track of all the numbers that are going around. So we are going to be thinking about 4 boxes, and each box has 2,125 toys. Okay, so these boxes are getting delivered to like some toy store or something. Okay, that's a lot of toys. So what we're thinking about here is what the multiplication symbol stands for. It stands for groups of. Make sure you remember that, especially when you get to 5th grade. So we have 4 groups of 2,125 toys, and our goal is to find out if we have 4 groups of 2,125 toys, how many toys is that altogether? Okay, so when you've been practicing 2-digit by 2-digit and perhaps 3-digit by 1-digit, you have been thinking about perhaps keeping one number whole and splitting up another number, breaking one number apart. You might have also been using the area model as a representation, okay? So what's cool about when we get to 1-digit by 4-digit is you're gonna take all of that understanding you already have and we're gonna apply it to this. So once we get going, you're gonna say, oh, I see, we just have a 4-digit number instead of a 3-digit number. And that's exactly what's going on, okay? So let's get started. I am going to draw an area model. When we're thinking about the area model for multiplication, okay, we are thinking about the space inside is going to be our product, the total space inside, okay? When we think about area, it is length times width, length times width. So what we're going to be thinking about is 4 as the length of this area model. And if I was thinking about how much longer 1,000 or 2,125 should be compared to 4, it should be a lot longer. So I just made that a little longer. So what's going to happen here is from here to here is going to represent 2,125 as the width. But what I want to do is I want to break up 2,125 so it's a little bit easier for me to work with. Okay? So is this the only number we have to break up in this situation? No, but I'm going to do it this way first. I'm going to try to show you all the different ways to think about this in this quick video. All right, so one way that we can break up a number is by place value. Okay, so cool thing about when your teacher taught you expanded form is you can use that when you're doing the area model. So when I think about the digit in the thousands place, it's 2, and that represents 2,000. So my total width has to be 2,125. Okay, so I'm going to split this up by place value. First I'm going to put 2,000 here. Then I'm going to put, again, it should kind of represent the size of these numbers. 2,000, I'm going to take the 1 from the hundreds place, and that represents 100, 20, and 5. So when we think about the width, I see 2,125. Now, an important thing, parents, if you're not familiar with the area model, is that opposite sides in a rectangle are equal. Okay, so when we think about what we're multiplying with length times width, we have length is 4 times width of this box is 2,000. Okay, but I know that this, from here to here, the length is 4, so I know from here to here, the length is 4. The width is 100. I know for this rectangle, the length again is 4, the width is 20. Okay, so I know since opposite sides are equal, I know what I'm multiplying in each box. Okay, this can also be recorded with equations, which I will do on the side over here and hopefully not run out of space. Okay, so we're going to be thinking about first 4 times 2,000. Okay, so in this rectangle, 4 is the length, the width is 2,000, and your student knows 4 times 2 is 8. So if my factor gets 1,000 times bigger, my product gets 1,000 times bigger. So I know if 4 times 2 is 8, 4 times 2,000 is 8,000. Okay, so they know this relationship. They know 4 times 2 times 1,000. And we see that, do you see the 2,000 here? I just want everyone to understand what's going on because I love math. All right, so 4 times 2,000 is 8,000. Then we know what we're going to what the area is going to be of this rectangle is going to represent 4 times 100. Okay, so 4 groups of 100 is 400. So what I'm doing is I'm keeping 400 whole. I'm splitting up 2,125 by place value. So far I've done 4 times 2,100. And so far, how many toys do I have total? 8,400. You can see that up here as well, and you see the 2,100 here. Okay, so then I'm thinking about 4 times 20, which is 80. And your student knows 4 times 2 is 20, but 4 times 2 is 8, so they know 4 times 20 is 80. And then we have 4 is our length here, because we went over how opposite sides are equivalent in a rectangle. So 4 times 5, we're finding the area of this little rectangle here, is 20. I knew I was going to run out of space. So we have 4 times 5 is 20. So do you see the 4 we kept whole? And we did 2,125. And you see it here too. But we're not done, because our goal was to find the total area or the total number of toys if I had 4 groups of 2,125. So because of the lack of space, I'm going to go over here. We take our subproducts, these are called, and we're going to add them up. And you can use the standard algorithm if you want. Some of you could already see what the total was. So how many toys do we have? 8,500. Okay, so we could break up the 2,125 by place value, but is that the only way to solve? You know that it's not the only way to solve. Okay, so let's think about it another way. What if I wanted to keep 2,125 whole? So let's think about that. What if, sorry if my rectangle's not perfect, we wanted to keep 2,125 whole, and we wanted to split up 4, but we're not going to split it up by place value. We could think about it as 2. So we want this total dimension to equal 4 and 2. Well, how about that? So I think that some of us are saying, wait a minute, 2 times 2,125, I can do that. And then I just do it a second time? Okay, let's try it. So if I'm thinking about mental math, I'm thinking 2 times 2,000 is 4,000. Then I'm thinking about 2, and I can just think about 125 together if I wanted to. So I know 2 times 2,000 is 4,000. I know 2 times 125 is 250. So 4,250 would be the area of this rectangle. And I know that opposite sides are equal, so the width of this rectangle is also 2,125. The length is the same. So you're saying I just write the same thing again? So I only had to do the work once? And it's less steps? Oh my goodness. Okay, so what we just did was we did 2 times 2,125. So I did 2 boxes of 2,125 toys. I got 4,250. Then I did 2 boxes of 2,125 again, 4,250. Sorry, I keep running out of space. So now I take those 2 subproducts, because this stands for 2 groups of the toys. This stands for another 2 groups of the toys. So I have to combine them so that I have all 4 groups of the toys together. Okay? And there's still so many other ways to think about splitting up these numbers. Okay, so one more way and then we'll move on to the next one. I'm not going to show with the area model to save a little time, but I will show you with equations. Some of you might be thinking, well, I'm going to keep 4 whole and I'm going to put 2,000 toys in each box to start. Okay, so that's 8,000. Then so you might be thinking, well, I have to put 125 toys still into 4 boxes. So I need to add 4 groups of 125 toys. And this might be something that you're thinking might be easy for you in your head. And then I have to figure out what is the total number of toys I put in when I did 2,000 in each of 4 boxes. And then I did 125 in each of 4 boxes. And you might find that you have 8,500 toys again. Okay, so what just happened was I kept one number whole for the most, I kept one number whole and I played with breaking up the other number in different ways. Okay, so let's move on to a new one and I'm going to show you even more things that you can do when we're thinking about multiplying a 1-digit number by a 4-digit number. Okay, so new example, and then I'm going to give you a bunch to try on your own, practice splitting up in different ways. So, sometimes we're going to have numbers that look like this. So we're thinking about 6 groups of 2,400. So this time I have 6 boxes, and in each box I'm going to put 2,400 toys and ship them off to the store to be sold. Okay, so we have the other strategies we just went over. So I'm just going to go over a couple of them really fast, and then we're going to think about another way to solve this problem. Okay, so let's think about keeping 6 whole, and we can split up 2,400. You could split up 2,400 any way that you want, so there's place value. We could put 2,000 toys in each box to start. Then we could put 400 toys in each box to start and combine so that we have 14,400 toys. Okay, so I split it up by place value. So that's one way to think about it. Or some of you might be saying, and I'll show with equations this time, I'm going to put 1,200 toys in each box because I know 6 times 12 is 72. So I know 6 times 1,200 is 7,200. When my factor gets 100 times greater, my product gets 100 times greater. And then I know that I could do this 2 times because I split 2,400 into 1,200, 1,200. Okay, so then how many total toys do I have? 14,400 toys. Okay, so there's a couple different ways to split up 2,400. We could also think about keeping 2,400 whole and splitting up the 6. So we might have students say, well, I'm going to do 2 groups of 2,400 first because I like working with 2. That might be happening. Okay, so they know 2,400 plus 2,400 is 4,800. How many times do we have to do that? So I have 2 groups of 2,400 toys. I'm going to do another 2 groups of 2,400 toys. So far I have 4 groups of 2,400 toys. And I know that I could do it one more time and add up the total there to show, do you see the 6? 2, 4, 6? 6 groups of 2,400 toys. So in this case over here, I kept 2,400 whole, and I broke up the 6 into 2, 2, and 2. Over here, I kept the 6 whole and split up 1,200. Okay? Students might also be doing this in their heads, which is really exciting. They might be thinking about 6 times 24 times 100. Okay? Do you see the 2,400 here? Okay? What's exciting and special about multiplication is that when I split up 2,400 into 24 times 100, I can multiply these two first and then multiply by 100, and the amount doesn't change. So this is something that students are thinking about in their brains, and I want to point out to you what's going on. That they know how to multiply a 1-digit number by a 2-digit number, and a lot of us are doing it mentally right now because that's something that we've been practicing in our classrooms over and over again. So if they recognize that 2,400 is 24 times 100, we can think about 6 times 24 and then make it 100 times greater. So in our students' brains, what we're thinking about is 6 times 20 is 120. 6 times 4 is 24. So in our heads, we're holding on to this information. 6 times 20 is 120, 6 times 4 is 24. So I know that 6 times 24 is 144. And for a lot of us, this is something that we've been practicing mentally all year long, and that's what we want us to start applying. So now that we've done 6 times 24, we can make it 100 times greater. And we also have been practicing what happens when we do that. So 144 times 100 is 14,400. So that's a really special strategy that students can use when they're thinking about, oh, it's overwhelming to multiply by 2,400. You can say, but I know how to multiply 6 times 24, and then I know how to multiply that product by 100. So we can break apart 2,400 into 24 times 100, multiply the 6 times 24, and then multiply it by 100, and the amount is not going to change. This is a special property in multiplication, okay? No need to know the name until you're older, but it is something that we can do with multiplication. It comes up in everything else that we learn throughout the elementary years. So important to know that the amount isn't changing, okay? So let me give you some to try on your own at home. All right, so you are going to try 5 groups of 1,560. You are going to try 3 groups of 2,800. And you are going to try 7 groups of 2,350. And I want you trying to break up the numbers a couple different ways for each one. All right, the area model is always available for you to use to help you represent what's going on. But try keeping the 5 whole and splitting up 1,560 in several different ways to multiply. Okay? Try taking 3 times 28 times 100. Okay? Or try taking 3 times 14 times 2 times 100. I don't know. Split it up in many different ways. It's fun and exciting. Okay? All right. I can't wait to see you in the next video. Bye.